Hello all. In this video, I am discussing about simple pendulum, which is taken from the 11th class, usually asked for 5 marks. Okay, so for this, we'll start with the simple diagram. Okay, for this, let me consider a rigid support here, which is connected by a small thread, which is flexible. Okay, weightless, inextensible thread, and which is connected by a small bob. This is a metallic body who's having the mass m. Now the whole system is considered as a simple pendulum, which has rigid support, a thread, and a mass. Metallic bob. Initially, the bob is at point O, which is considered as a mean position or equilibrium position, which is not yet started its oscillation. Now the pendulum is allowed to oscillate freely from one point to the another point. Let's see that when you allow the body to oscillate, okay, just imagine the bob will come to the point O from O to A. Okay, now we can consider this displacement is from here to here is x. Okay, and the angle traced by the pendulum is taken as theta. It moved from O to A and the displacement is taken as x. And the length of the string is L. When the body is at A, which will be acted by two forces. Okay, one is downward force, which is considered as a W equals mg, where m is the mass, g is the acceleration due to gravity. And another balancing force, which is acting along the thread in this direction, okay, where W is splitted into two rectangular components. Okay, one is along this, where tension is acting along the thread here, which is taken as T. Tension is the balancing force which allow the thread to be stay in the straight bendless form. It is not bended. So that is the tension. And this is balanced by mg cos theta. And another force which is acting in this direction, that is taken as mg sin theta, where W is splitted into two rectangular components. One is mg cos theta, another one is mg sin theta. And here we have to observe that when the pendulum got displaced from O to A, that is x, due to the inertia, it will reshoot into the original position O, right? Because of the restoring force. There is a restoring force which will bring the pendulum from A to O. Is it right? So that is restoring force. So now there are different forces are acting on the body. One is weight mg, which is splitted into two rectangular component. One is mg cos theta, which is basically balances the body. Another one is bring back the body to the original position, that is mg sin theta. Okay, number one, let me take it as a W equals mg. Number two, tension, which is acting along the string here, T. Correct? Again, W is splitted into two rectangular components. W equals mg. One is mg cos theta, Another one is mg sin theta. Now, what I can do here is mg cos theta acting opposite to the tension. So, both will get cancel each other here. Acting along the thread, balance the tension T, and both are opposite to each other, so they will get cancel each other. Next one is mg sin theta acts like a restoring force which will bring back the body from A to O. So then I can write it as restoring force F equals mg sin theta. I'll take minus here because restoring force always acts opposite to the displacement of the body. The body is displaced from O to A, but restoring force acts in the opposite direction. Hence, I have taken minus here. Now, what I can write, theta is very small. Then sin theta is taken as theta only. Maybe it is very small angle. So directly we can take it as sin theta as theta here. Then what is theta here? Now what I will do, F equals minus mg into theta. Then from the figure we can say, so theta is the angle. Angle equals what? Angle equals arc by radius. That is the basic formula. And here, what is the angle theta? Arc is the x and radius is the l. Then I can write it as theta equals arc is OA, then radius is L. Then theta can be taken as theta equals x divided by L. Then the above equation can be rewrite it as F equals minus mg into x by L. Right? Then from Newton's second law of motion, F equals ma. Now we can compare with the previous equation. F equals minus mg into x by L is there. So now F equals ma. So then comparing with above equation, I can write it as ma equals minus mg into x divided by L. where m and m will get cancelled here. Then we can write A equals minus G into X by L. And then again, further we can write it as where omega square equals G by L. Then the above equation can be written as A equals minus omega square into X. And from this equation, I can write it as A is directly proportional to what? Displacement X here. But here, this is a constant. Omega square is a constant here. Okay. So now A is directly proportional to the displacement X, but both are acting in the opposite direction. So I can write it as acceleration A is directly proportional to the displacement. There is a more displacement from the mean position, then the pendulum body will come back with a more acceleration. So this is the final expression for simple harmonic motion of a body or simple pendulum. Now furthermore, we can write it as here. We know that the time period of oscillation is taken as t equals 2 pi by omega. But from the previous equation here, I can write it as omega equals what? Square root of G by L. Now let us substitute the same here. So t equals 2 pi divided by square root of G by L. If you take the reciprocal, what will happen here? 2 pi into L by G. So which is the expression for time period of a simple pendulum. Then again further, if you want to write it as, then the frequency, we know that frequency mu equals 1 by t, and we have the expression for time period 2 pi into square root of L by G. Now I'll write the same here. 1 divided by 2 pi into L by G, which is again taken as a reciprocal. That is 1 divided by 2 pi into square root of G by L. So this is the expression for frequency. All right. So now here is the derivation. Hope it is clear. Okay. So this is the one of the important question we should study and understand in the 11th classes. Okay. And these are the important formulas we should memorize for solving the numericals. And also, if you furthermore, if you simplify this, seconds pendulum. What is the meaning of seconds pendulum? A simple pendulum whose time period a simple pendulum whose time period of oscillation is 2 seconds. I can say that a pendulum takes 2 seconds for one oscillation. Then if you want to find out the time period, we know that time period formula is T equals 2 pi into square root of L by G. We know that T equals 2 pi into square root of L divided by 9.8. Now, further, I can simplify as we know that the time period is taken as 2 seconds. So, T is taken as 2 here and 2 pi into square root of L divided by 9.8. Now, we have to square on both LHS and RHS. Then 2 square equals 2 into, that is squared, so it will become 4 pi square, and this square root will get cancelled each other. So we left out with L divided by 9.8. If you further simplify this, L equals 4 into 9.8 divided by 4 into 3.14 into 3.14. Further, if you simplify this, we'll get approximately equal to 1 meter. Then to achieve one oscillation in 2 seconds, then the length of the thread must be equal to 1 meter. If you want to say that the pendulum is a seconds pendulum, then the length of the thread is 1 meter. Then it will do a one complete oscillation in 2 seconds. If you want, we can further simplify this, saying that, the frequency, we can find it out. We know that frequency is the reciprocal